Hi, this is from our log packet, Unit 2, Topic 1. Today's lesson is called LogArithmetic. So, some of the rules that we learned, the log laws, are going to be used to solve problems. One of the rules, or two of the rules we learned, had to do with multiplication to addition and um, division to subtraction. And so we're going to use what we know about those rules to simplify problems from division and multiplication to addition and subtraction to make our log problems easier. This is one of the best uses of logs, especially in the days before people could do log calculations on their calculator. So you can see above, we've got use the values that are given and the ones you know by definition. So I've underlined log base 2 of 2 equals 1. To figure out each of the following values, explain what you did in the space below each question. So they give us a log bank, and in the log bank, they tell us letter values representing log base 2 of 3, log base 2 of 5, and log base 2 of 7. So in addition to log base 2 of 2, we're going to use those definitions as substitution for some of these log problems. So number 4 says log base 2 of 9. If you look at our sort of number bank, there is not a definition or letter associated with log base 2 of 9. So we're going to break 9 down into multiplication. We're going to change log base 2 of 9 into log base 2 of 3 squared. Now that's actually the power rule, so we'll be using that as well. And we know from the power rule that we can move 2 in front of our log as the coefficient since it's the exponent of the argument. They give us a definition of log base 2 of 3, so the answer becomes 2 times a, which represents log base 2 of 3. There is another way to do this problem, and that is to break 9 into log base 2 of 3 times 3. If it's log base 2 of 3 times 3, we can also make the problem log base 2 of 3 plus log base 2 of 3. When we add the two log base 2 of 3's, they both represent a, and a plus a is, again, 2a. 10 is going to be broken into. It can't be really made into an argument with a exponent. So we're going to change it using the power rule, not the power rule, sorry, the product rule. And the product rule says that log base 2 of 10 is the same as log base 2 of 2 times 5. So if I've got log base 2 of 2 times 5 using our product rule, we can change that into addition. Log base 2 of 2 is 1 from above what I underlined, and log base 2 of 5 is also defined as being b. So the answer to 5 is going to be 1 plus b. As we go along from here, I'm sure you have the idea of what we're doing here. It would be a good idea to pause when you can and try these on your own before hitting play on the video and seeing what the answer is. Log base 2 of 12 can be rewritten as log base 2 squared times 3, or log base 2 of 2 times 2 times 3. Changing our product to an addition rule, log base 2 of 2 plus log base 2 of 2 plus log base 2 of 3 is 1 plus 1 plus a, or 2 plus a is the final answer. The next problem, number 7, is actually the quotient rule. The quotient rule changes into subtraction. So I'm going to change log base 2 of 7 divided by 3 into log base 2 of 7 minus log base 2 of 3, in which case we're going to have C minus A from the number bank above. Again, for log base 2 of 30 divided by 7, that is also the quotient rule changed into subtraction. So you want to break 30 in particular into multiples in the argument that obviously multiply to 30, but are also represented above in our number bank. So if you remember, we have log base, well, let's change it first into the subtraction rule, log base 2 of 30 minus log base 2 of 7, and then we can change 30 into log base 2 of 2 times 3 times 5, because those all add up to, multiply to 30. And then log base 2 of 7 is defined above. So we're going to change log base 2 of 2 times 3 times 5 using our addition rule. And at the very end, we're going to subtract log base, that says log base 7 of 7, but as we already know, they all have to be the same log. So it should really be log base 2 of 7. So log base 2 of 2 is 1, log base 2 of 3 is A, log base 2 of 5 is C, so it's going to be is B, and log base 2 of 5 is C, so it's going to be 1 plus A plus B minus C. For the last one, number 10, the 9, you're going to have to use a factor tree in order to break 486 into logs that are listed in the number bank. So I'm going to do a prime factorization over here. I just exposed it. So 486 can be broken down into 2 times 3 times 3 times 3 times 3 times 3. All of those multiplied together equal 486. So that's going to be 3 to the 5th power times 2, which is what we're going to change the argument to. Once we change the argument to that, we're going to use our product rule to change it to log base 2 of 2 plus log base 2 of 3 to the 5th power. Then we're going to use our power rule to move the 5th power to the front of only our log base 2 of 3. Once we do that, we can use the letters above to say log base 2 of 2 is 1, and 5 times log base 2 of 3, which is A. So final answer, 1 plus 5A. For number 10, it says, well, what other logs would we need in order to figure out log base 2 of any number? Well, if we have log base 2 of 2, we've got the only even number we need. The only other ones we would really need would be other prime numbers. So anything that's not a multiple of 2, 3, 5, or 7, which are the arguments already represented. So other prime numbers that would be useful could be 11, 13, 17, 19, etc. On page 22, these are going to be sometimes true, always true, or never true based on our understanding of the log rules. So I'm going to do the first two, and for the rest, I suggest that you hit the pause button if necessary, and try these on your own before replaying the video and seeing the answer. So it says log base 4 of 5 minus log base 4 of x can be changed into the quotient rule. And as we already know, if we want to compress or contract a log from subtraction, that's going to change into division. So this one is going to be only sometimes true. And the only reason we're saying sometimes and not always is because remember, when we do the quotient rule, we cannot divide the argument by 0. The argument cannot be 0 and the argument cannot be divided by 0. So we're putting the answer sometimes to define the domain as having to be x larger than 0. For the next one, it says log base. Now remember, there's no base there, so that's a common log. So it's all base 10, log 3 minus log x changes into log of 3 over x squared. So again, using the quotient rule, 3 would be in the numerator of the argument, and x times x would be in the denominator of the argument based on the quotient rule. And once again, we'd have to say that x would have to not be 0. It could be negative. That would be fine. The reason 11 can't be negative is because you cannot have a negative argument in a log. But x squared in the denominator, that makes any number except 0 positive, and so that would make a positive log argument. So unlike 11, you could use any number except 0. Pause and try 13. 13 is never true because that's not a log rule. Subtraction does not contract into a log over a log. Something like that looks like a change of base rule for log, which you haven't learned yet. We should be probably learning that tomorrow. But 13 is never, because that's not the log rule, or it's mixing two log rules together. 14 is just the power rule. And again, we're just saying sometimes, because once again, your argument cannot be negative or 0. So you must define the domain as, yes, it's true as long as x is greater than 0. For the next one, 15, it looks like they're trying to use the power rule, but it went from addition to addition. Well, when you're doing a contraction, you don't go from addition to addition. You go from addition to multiplication. So this one is never, it's not a log rule. Number 16. 1/2 log x is the same as log square root of x, because if you move the 1/2 to the argument using the power rule, you first have log base 10 of x to the 1/2, which is the same as log square root of x. And again, that will always work as long as x is greater than 0. The subtraction in 17 doesn't make sense. In order to change it to division, it would have had to been log base x, log of x minus log 5, and then that would have contracted to log of x over 5. 17 is not a rule, so that one is never. So that's the end of our lesson for today. Please try your